So we're on the worksheet manipulating the ideal gas law, and sometimes we are going to use that density formula that we started with, but other times we need to use all our knowledge to figure out exactly what they're asking, okay? So here they give us grams, so it seems like you can just go to moles, but we don't know the kind of gas it is. But they do give us our liters, our temperature, and our pressure. Now the first thing to know is that we have enough information to use PV equals nRT, okay? And we're solving for moles. So our formula is PV divided by RT equals moles. And which R do we want to use? Well, we can use the R that's in atmospheres or the R that's in kilopascals, but we have this problem right here. Our pressure is in millimeters of mercury. So I'm going to convert that to atmospheres, and that would be 140 millimeters of mercury. I don't want millimeters of mercury, so I put it on the bottom, and I want atmospheres on top, and that's 1 divided by 760 millimeters of mercury. So go ahead and plug that in and see what you get. So you should have gotten 1.5 ATM, and then when I plug all that in, we get these numbers. I use that R, which is a liter ATM K mole. So ATM crosses out, my liters cross out, my K's cross out. That's on the bottom, so that gives me the right answer in moles, which if I round to the correct sig fig is 1, 2, 3 moles. Now, I want to remind you, we multiply by things that are on the top, we divide by the bottom. So it's 1.5 times 2 divided by 0.0821 equals, and then divided again by 298K. Yes, these two are multiplied on the bottom, but since they're on the bottom, we divide it from this number. Okay, now recall that molar mass is nothing more than grams per mole. That's what molar mass is, and they want me to find out what the molar mass is. So they gave me my grams, which is 3.43 grams divided by 0.123 moles, and you will get 27.9 grams per mole. So now what's going on here? We need to figure out, if I know this molar mass, can I determine what gas it is? Well, the key here is that most gases are diatomic for what we've been talking about. So that means there's 2 of them. So I should have roughly 14 grams per mole, because 2 of them would equal 28, for 1 atom, okay? And that 1 atom is probably nitrogen. Okay, so now let's go through some of these other guys, okay? What's the number of moles? And so you can use your PV equals nRT. And then once I find the number of moles, it says, what's the mass? Well, once I know moles, I convert it to mass. Why? Because we know this is oxygen gas. So we can go from grams to moles and moles to grams using molar mass. Another thing that might trip you up is it gives you the density at room temperature is this. That's the density, so make sure you plug that in where density goes. So in number 4, remember it gives you that it's carbon dioxide, so you would know the molar mass of carbon dioxide in number 4. So those are some tips. This is critical thinking, putting together all your knowledge and determining how are we going to use our formulas to figure out the questions that they give you.